Okay, hello. My name is Mark Pascal, I'm Director of 3 Months. 3 Months I also organise the Ethereum NZ conference for those of you who came along, and I'm co-organiser of this meetup and the Wellington equivalent. Just a bit of housekeeping, so the toilets are out the back there and to the right, around the back there. A few bits of news in the blockchain space. So those who don't know, blockchain.org.nz is now live. So Stephen Castle is sort of leading that. So this is a national organisation to bring together and coordinate various events and stuff. And blockchain in New Zealand, which is awesome. We've just renamed, just half an hour ago, renamed this meetup group to Blockchain Auckland. And we've got similar Blockchain Wellington now to try and bring together some of these disparate meetup groups, coordinate things. We're in the process of setting up Blockchain Labs, which is going to be a partnership with AUT and a bunch of other people, and it's going to be a vehicle to help research and commercialise blockchain-based projects in New Zealand, so it's very exciting. So we're really keen to connect with people in this space. So if you're technical, if you've got an idea, or you've got lots of money. So really excited to have Arthur over here. So Arthur is a Kiwi working in New York for a company called Consensys, who are doing some of those. They're probably a world leader in the Ethereum blockchain space.
Definitely, yes.
I will let Arthur introduce himself.
Thanks, Mark. So my name's Arthur Falls. I work for Consensys, which is a blockchain-oriented venture production studio. So what we do is we use the power of the blockchain to iterate on existing business models that we see in the world today, and try to bring the world something new and advance the technology itself. And the way I actually got into the whole blockchain space was the same way as everyone did, and that was through podcasting. And that started in 2014. I had a podcast, Beyond Bitcoin. And then 2015, I had another one called the Ether Review, which was based on Ethereum. And I was kindly invited to join Consensys at the start of this year, where I've been managing the blog and producing a podcast for them called State Change, which is about internal Consensys projects. It's a short format podcast, so I recommend it. It's designed to be easy to churn through and get a full understanding of the technology that Consensys is working on, which in my opinion, of having spent 3 years watching the space, which is actually a long time, apparently, these days, is actually some of the best technology out there. Genuinely, I'm really excited about it. So that's me. This is the second time I've spoken in public, and actually also, and the other time was the first time I produced this, so excuse any spelling mistakes you might encounter. There were some fancy digital graphics that I had, but based on feedback, I've taken out all the jokes, all the graphics, and no, I'm serious. So the state of the blockchain, a biased overview of distributed ledger and verifiable computing technology today, innovation today, that's what it says. Framing the discussion. So when we say blockchain, it invokes, or Bitcoin or Ethereum, it invokes a bunch of this impression of an impregnable and revolutionary technology that seems to have just emerged from the ether, so to speak. But it's not from Mars, it's not alien, it's been in development for a really long time. And like the computer, the story of the blockchain is nested in the story of cryptography. Part of the reason blockchain seems so alien as a technology and so hard to understand is that its development is nested in between two dark ages. And the reason that I call them dark ages is that there are times when development in the technology was unable to penetrate into the public consciousness. And those two dark ages are the World War II, and following that the Cold War, which was a massive block of time, and then the burst of the dot-com bubble and the appearance of Bitcoin. And so what you had with between those two times were a curious opaqueness where we just didn't see anything developing. But in fact, work was being done behind the scenes. Contemporary blockchain technology can be assembled from the components that we see in this, this golden era that occurred between basically about somewhere between 1976 and 1985 is when the first kind of dark age sort of ended, and then about kind of the year 2000 when the dot-com bubble burst. And so by examining the way these innovations are being combined, we can understand the direction and the state of blockchain technology development. So, history. But there were these three guys, Whitfield Diffie, Martin Hellman, and Ralph Merkle, and they, at the end of the 70s, they were developing the fundamental building blocks of all cryptographic deployments today. And those were asymmetric key cryptography, known as public key cryptography, and also cryptographic hashing. And while I'm not going to go into what these exact things are, I do suggest, does everyone know what those are? What asymmetric key, what public key cryptography is? Does everyone get that? Can we have a show of hands? Cool. Sorry, Cowan. And cryptographic hashing, right? Everyone, yeah. Well, if you get public key cryptography, I'm sure you get cryptographic hashing. What's really interesting is that public key cryptography was not first developed by these three guys. A bunch of poor, downtrodden cryptographers at the British intelligence agency, the GCHQ, they developed it first. But of course, their names are lost to history because they were sworn to secrecy in the development of that tech. So in 1985, this guy, David Chaum, took public key cryptography and hashing, cryptographic hashing, and came up with this idea for a way to create a digital currency. And he did this. He released this idea in a paper called Security Without Identification, Transaction Systems to Make Big Brother Obsolete. And the reason it's worth remembering the title of that paper is that that is the gunshot that started the cryptocurrency revolution. Even though we think of it as Bitcoin, that was when this started, and that was way back in 1985. In 1990, he created the DigiCash company, which ultimately developed DigiCash, which is alive today in Sydney, crazily enough. In 1994, this fellow Nick Szabo, who knows Nick Szabo, or knows the name Nick Szabo? So some people. So Nick Szabo was he was a legal scholar and cryptographer and computer scientist. And what he realized was that you could take an agreement between people, and if you could make that, if you could create an environment in which that agreement could be guaranteed to, in which a computer program representing that agreement could be guaranteed to execute, you could equate a computer program to an agreement, an agreement between two parties, which we know of in the legal world as a contract. So take, for example, a direct debit with a bank, right? You know, when you sign a thing on your gym membership that you're never actually going to make use of, and that money gets taken out of your account every month. There's a sense in which that is a type of contract. And so that's kind of that was the innovation that Nick Szabo was or the realization that Nick Szabo made back in 1994. In '96, with there weren't parades in the streets, but it was a really significant time because a period known as the crypto wars, which is totally worth reading up on, ended. And cryptography, strong cryptography, unbreakable cryptography, which was previously restricted to the use of, it was classified as a military technology by the US government, was reclassified as a commercial technology. And what that meant was we could suddenly transact over the internet. And that is what led to the dot-com bubble. Often you wonder, like, why was there, the internet had been around for a while. So why did suddenly this dot-com bubble happen? Well, this is what it was. It was the reclassification of strong cryptography that allowed us to send credit card numbers over the internet. And so pets.com was something we have to thank for that. In 1999, well, in 2000, that dot-com bubble burst. And so that is the end of, the year 2000 is the end of the golden period where suddenly there was all of this money flowing around and everyone was just free to develop their crazy cryptographic ideas. During that time, this fellow, Adam Back, who is now engaged at Blockstream, which contributes a lot to the Bitcoin core, he developed this idea called Hashcash. And the idea of Hashcash was that you would use a difficult to solve problem to create a validation code that you could include with an email. And what that meant was that it was because it was computationally hard to produce this code, it was hard to send an email, but it was easy to validate the code. So the idea was this could help prevent spam. But it never, as we know, how many people used Hashcash? Virtually no one. It was an interesting idea, but one that later proved to be really important. So between 2000 and 2008 is the second dark age. And part of the reason it's significant is that a lot of the stuff that we're seeing now being developed is built from these basic components. For one, everything is built from public key cryptography and cryptographic hashing. Then this concept of cryptocurrency, the digital money, smart contracts, and Adam Back's Hashcash. In these ideas is basically everything that we need to build blockchain technology as we know it today. So in 2008 and 2009, as we all know, Bitcoin, the white paper and the network itself emerged. In 2011 and 2012, people started realizing, hey, just as we can do new things just as David Chaum realized that by combining hashing and public key cryptography, we can build a currency, people started to realize there's more to a blockchain than just currency. And with Namecoin, there was this idea of a public and decentralized domain name service where no one was in control and those names could be permanently and irrevocably registered on this public and global resource. Then we also saw in 2012 Peercoin. And while I was doing this presentation before, there's so many ideas that you want to cram into it, and proof of stake is a major one. But trying to actually differentiate between mining and proof of stake to a less than anything but the most hardcore cryptocurrency audience can be a bit challenging. So what it did was basically, instead of using the computational resource, instead of balancing security of a network against a computational resource, which is what happened with Bitcoin, instead this balances it against a monetary penalty. So if you misbehave on the network, you have a monetary penalty. I could probably put that more elegantly, and I will iterate on this presentation. So 2013, Mastercoin. Mastercoin was the idea, hey, we can actually use this for more than just domain name registry. We can use it for more than money. We can use it for probably everything, actually. This is kind of a can opener, you know. There's all kinds of food in cans, and so we can find a way to really extend this technology. And so with Mastercoin, the idea was to create a protocol that people could build on top of, a sort of generalized layer for Bitcoin. And so I called 2013 the year of promises, because that was the year when people started to say, hey, we can do this, we can do that, we can do everything. You name it, we can do it. Blockchain has the answer. World peace, no problem. People still say that, and I believe it too. I have to say I am of that ilk. 2014 was the year when those promises were attempted to. People tried to realize on those promises. It was an altcoin boom. Does everyone? So for those who were around during that time, that was like the age of Dogecoin, and Bitcoin.
It was very funny. It was a very odd time.
It was cool. I mean, I never bought Dogecoin. Yeah, it was, and it's a, Shih Tzus or whatever. Is it called a Shih Tzu? Shiba. What's a Shih Tzu? I don't know. It's probably a doll or something. Yeah. So there was the altcoin boom, and then there was this idea that we need to iterate on the Mastercoin concept because this is not working, and because it didn't work really, Mastercoin, and so we had a whole bunch of new Bitcoin 2.0, as they call them, protocols that themselves never really went anywhere. And so that's why I say it's Bitcoin 2.0 version 1. 2015, back to the drawing board, basically. That was the year when, where's the decentralized naming system, Where's the global identity system? It just didn't exist. And so everyone went back to the drawing board, and out popped Ethereum, the magical golden goose that, as we all know it today. And so 2016, that's this year, that is the rise of the dApp developer. So instead of producing a whole bunch of new protocols, people are building new applications on top of a bunch, an ever-growing, actually, number of existing platforms. But Ethereum is vastly dominant. There is value in some new new platforms, though. And so 2017, what's that? Maybe we'll find out in the final slide. It depends. I can't remember if I wrote anything in there yet. So let's see. So what are the components? The major components, as said before, are public key cryptography and cryptographic hashing. Hashcash, proof of work consensus, plus DigiCash is basically all cryptocurrency. Cryptocurrency plus smart contracts gives us these these programmable blockchains that we all have access to, a global, programmable, flexible, verifiable computational resource. And then if you take away the public consensus, the public side of that programmable blockchain, what you get is something that is really beautifully tailored to closed enterprise solutions, which people find boring. But it's not revolutionary, it's not going to change the world. It may not change the world, but if it makes business more efficient, more reliable, and it can enable new business models, it can open up new opportunities for enterprise and entrepreneurship and stuff like that. I know we don't all like the banks, and we don't need another Samsung, but there's stuff there too. And I mean, Uber's great, right? So where are we now? Distributed ledgers that store programs. That's these blockchains that have cryptocurrency, that have smart contract capability. Instead of having a account balance behind an address, what you can have is a piece of code that performs an operation. And because that piece of code exists in a globally available, secure state, secure environment, and you can be sure that it will execute, suddenly we're able to base our behavior on the existence of a particular piece of code at a particular address in this publicly accessible, globally publicly accessible computational resource, distributed ledger. So today we have a focus on formal verification and functional languages. I'll actually come back to that one. So modularization. We're starting to divide up some of these cool things that we're seeing in these new blockchain platforms. Things like you don't necessarily need to have the same blockchain and the same execution engine. And the example of, or the same consensus process. The first example of that would be the enterprise deployments that do not use a public consensus mechanism. Instead, they just have permissions. Do you have write permission to the blockchain? Do you have read permission? etc. Then you have, or what exactly is the nature of your right permissions. Then you have, and that is so that's what's led to a whole bunch of enterprise deployments. So we also have this high velocity crowdfunding. So I'm not going to mention the DAO. Has anyone seen, so is anyone aware of First Blood? It was weird, right? I've never seen anything like it. 5 million in like seconds. How many seconds? 10 seconds. I just looked that up today. Absolutely amazing. And I mean, for those who remember Digix, does anyone remember Digix? Ah, yeah, I'll invest in that. That's a really great idea. 5 million in 12 hours, So it's incredible. Singular DTV, similar story. The velocity and the willingness to invest into these crypto projects is these dApps. This comes back to the rise of the dApp developers. The amount of funding that the public is willing to throw at these guys is phenomenal, and this leads us to the second point that I skipped over, a focus on formal verification and functional languages. If we put money behind these projects, these programs that are stored in these cryptographic ledgers, and we don't fully understand how these programs operate, all kinds of crazy things can happen. And so, while Solidity, which is the language that powers Ethereum, is incredibly versatile and capable and secure to a point, as we've seen, it's certainly secure. It is itself secure, but it's a language that we do not necessarily fully understand. And so that's why there's been this drive to adopt functional languages like, with similarities to Rust and Haskell, in order to create these contracts. And this is really a hangover from the flexibility of Turing completeness. If you have the ability to write any program, how can you be 100% sure that you've written the program that you meant to write? So what are some good examples of the way this is being used? The flight delay dApp. Has anyone seen the flight delay dApp? It's pretty awesome. It actually works. Well, it did work. They've stopped. They've taken it offline, but it was an awesome idea and worked beautifully for the time that they were using it. Apart from a couple of bugs, I spoke to them at DevCon actually, and they were like, "Yeah, it's been awesome, but we've decided to put a halt to it due to some weird behavior that they found in their code that they did not anticipate." But the basic idea is that what you do is you model how many times flights are late, and then you put you use that to determine the cost of paying out for those late flights, and then you just allow people to pay a certain sum of money that will be able to cover the total cost of paying out when those flights are actually late. So you have a trend toward a zero-sum game where there is no actual money necessarily to be made there, but at least we all get paid out when our flights are late. It's not like it's classic. Instead of a actual business, you've got perfect economic efficiency. It's really incredible. Uport is another example of a dApp that's out there right now. Well, not out there right now. It will be next year. It's focused on identity, and for those who, I know we were talking about identity before, it can be hard to describe and explain to people the value of owning your own identity. And it comes back to the idea that Facebook controls all those photos that you uploaded, and Google has access to all of those emails. But wouldn't it be nice just to actually have total control of that stuff yourself, and the ability to register things like your medical history with your own in an environment that you controlled, so that you do not have a third party that has access to information that might be sensitive and might be compromised in the case of a US subpoena, etc. It's a strange time where we're starting to realize that this being the information age, information itself is valuable. And when you give that to a central organization, as opposed to retaining control over it yourself, you lose control over that information, and in a sense you lose value and give over power over yourself, in a sense give over sovereignty to a central organization that you might not have voted for, but just by default have agreed should control this information. In terms of provenance, so provenance is the tracking of the authenticity or origin of an item or an asset. And a really classic example that we've seen recently is the BHP Rystone project, where the core samples that come from their exploratory wells off the coast of Australia in particular, they're taking those core samples and assigning them an ID on the blockchain, essentially a smart contract asset that tracks all the particulars about that core sample, and it can follow it as it goes from custodian to custodian until it ultimately winds up with the Australian government. And it can do that in a way that is perfectly transparent, and it can be seen by anyone in the system at all times. Cotricity is a particularly interesting example. It's a partnership between Consensys and RWE, which is a German utilities provider. And what they've enabled prosumers to do in select regions is to track exactly their solar output from their home-owned solar panels, and also track the consumption of local supermarkets, and pair those two numbers together so that the supermarket can pay the local producer who's feeding their energy back into the grid while they're at work and not using that energy directly. And the idea is, again, to further distribute the electrical generation and the wealth that can provide. Santander is a bank in the States. It's Spanish, I believe. Thanks. And they want to issue a fiat-backed cryptocurrency. Part of the reason for this is superior liquidity, the ability to transfer across borders, better traceability. It's a really powerful cryptocurrency, which I have actively not talked about at all, is incredibly powerful as a concept. And the idea of issuing fiat-backed cryptocurrency, if not fiat cryptocurrencies, right? I mean, why would you want to transact in paper dollars if you could actually have a government-issued cryptocurrency? It would be the liquidity of that and the ease of use is tremendous. So Santander's running a project there. And finally, Full Profile, which I just spoke to their CEO, Emma Weston, recently. And her view of this came from, she was a member of the Australian Wheat Board. And what was really cool about their idea was they found that in the point of first purchase of a commodity, in this case wheat, the purchaser would often use those, say, 30-day terms to exploit the producer as a source of credit. And the catch is that's 30 days of counterparty risk that someone who's just grown wheat has to worry about. And it's completely unfair, and it was just assumed that this is just how things are. But if we can create a system where settlement happens on the day, like we have the option for doing in a cryptocurrency system, then we can solve that problem and also create an entry point for provenance not only of these say core samples from exploratory wells. We can track the provenance of from the point of first purchase of all kinds of commodities. So what haven't I talked about? Decentralized storage. There are a ton of ideas out there around creating a way to rent out that spare hard drive space. In the same way that you want to find a way to sell that energy that you're producing from your solar panels while you're at work, there's also, of course, you want to, there's economic value in the spare hard drive space that you're not using. So why not sell it? And there's a bunch of ever iterating, ever developing projects around doing this. I can think Seacoin is one, Storage is one, and everyone's Swarm is another platform that's being built on using Ethereum as a trust layer. And then the most powerful of all, or at least the most broadly used of all right now, is called IPFS, which stands for the Interplanetary File Storage. It's super cool. Post-blockchain tech. So does anyone know who Dominic Williams is? Random question. Well, of course you do, Mark. So Dominic Williams is just this funny character. He seems to be around the kind of blockchain space. And he came up with this idea for a way to do basically everything blockchain does without the blockchain. And what's really cool about it is it's an example of someone learning the lessons that we've learned from this and saying, hey, maybe we can totally reorganize this, totally re-architect what we're doing and achieve some benefit. And his platform, Dfinity, at least in theory, I bring it up not because it's something that exists, but because it's something that has extraordinary claims for benefit, really could show us a new way of doing these things and free us from thinking about the new age of cryptography as being the blockchain age. Maybe it's not. Maybe it's the verifiable computing age. So there's a ton of awesome blockchain platforms and dApps and deployments out there. Tons of cool stuff. A lot of it is not fully operational yet. It's all in this proof of concept phase. But a lot of it's just incredible what people are building. There are humanitarian initiatives tracking vaccines in Africa, which turns out is a major problem. Quite ghastly actually, but not something I'm going to talk about today. Also, I think Bitto was. You guys are engaged in recording the You guys might be engaged in recording land ownership. Is that okay? Yeah. So the idea is that you can record the ownership of various assets in a blockchain, which is incredibly powerful. And then there's a whole bunch of interesting organizations involved in this right now. Consensys among them, but that's the only one I'm going to mention because they employ me. Final words. 2016 was the rise of the dApp developer. So 2017, we have to assume, will be the rise of the dApp. Enterprise platforms are now mature, and public platforms are approaching maturity. Did I say that that dApp stands for distributed application or decentralized application? I don't think I did. Yeah. So that's what it is. There's some nomenclature for you there if you weren't aware of it. We can have questions. Basic design principles for the way that we build these applications and these global networks are being developed, and that's giving us the ability to not make the mistakes of the past, which we've seen. Well, it's been a tough year, so hopefully we've learned. Hopefully we've learned a bunch of lessons, and that's all I've got.
Thanks for the talk, it was really great. I have a question just on the whole idea of, so you mentioned of course that the whole advantage of distributing is the transparency factor, and you mentioned there was rather more like commercial application where you basically say that you take the public consensus element out. And my whole question is, if you really do that, what is still, there's my real point that I still haven't understood, what's the advantage of still using the blockchain rather than a more centralized form, so another technology? Because I guess in terms of equipment, infrastructure, computational power, and all that, you're going to have a higher burden by using a blockchain versus using something more centralized. So if you do take that, that public consensus element out, what is the advantage in terms of a commercial perspective, or why do you think it will thrive?
So the reason that you take the public consensus out is that it's the public consensus that is the burden. So looking at the way the Bitcoin network is secured, you have a whole bunch of computers trying to solve Adam Back's problem, Hashcash problem, right? And the idea is that they're all working really hard, and then one of them solves it first, and that computer gets a reward, and gets to mint a new block. And so the idea is that eventually, that's why it's called a blockchain, right? And then so everyone takes that block, and part of that block is going to be part of the problem that needs to be solved to create the next block. And so all of these computers together are working to produce block after block after block. And that is really hard and time consuming to do. So the idea of if you can have a blockchain and remove that from it completely and just have basically a timer and just trust that no one in the network is trying to cheat, you don't need to have that, mechanism that for choosing a random person to agree on the state of the blockchain at any one time. Does that answer the question? Because
I wonder just which element needs to be done then on the decentralized computer. What needs to be done then locally? I guess that's my question. I guess what is left to do?
Yeah, are you trying to say like what's the value of having the distribution rather than just having it run locally?
Well, I guess if you take this element out, I just wonder what is left to do. What is left to be done locally? I guess is my question. Then
But why not just have a database?
yeah.
That's
Yeah.
I think the question, isn't it? It's
Yeah.
like is there something in the middle between full-on public distributed ledger versus just what banks have done since time immemorial, which is basically databases and built their own ledger? What's the bit in the middle basically?
Well, the bit in the middle is the distributed ledger itself. So what you can do
So
is
it's still distributed. It's just not publicly distributed.
exactly, yeah. So you can just have a node at every point of significance that needs access to that ledger, and then you don't have to go through the rigmarole of all this these consensus algorithms.
How do you secure that or figure out which is the right state though? What if you have a private one that forks?
It doesn't, because you trust everyone in the network, and if it does fork, you just stop it and just say, okay, what is actually real, and that's when the auditors.
Assumption. What if you have 500 banks and
And one of them does something weird, then maybe it's time for something a little bit more advanced than just a permissioned ledger, right? Maybe those banks could be running something like that. Then again though, because it's fully auditable and because you have the fallback of a legal system, whereas because you don't have anonymity, right? Or pseudonymity. Because on a public network you have pseudonymity, you can't fall back to a legal system because you can't necessarily connect a name to a person. Whereas in a permissioned network, you can connect a node to a bank or an organization or whatever. And
so if you always have to fall back to some trusted system that tells you which is the right one, like you said,
what's the point?
Database?
It's just because it gives you superior auditability, and it gives you
Well, no, you can still have all the auditability and you just publish it.
right, yeah. That's the question, right? I mean, that's the question that every deployment.
It is to do with levels of trust. So on the public blockchain, you have zero, very little trust, but on a semi-closed banking system with 20 banks, you kind of trust them a little bit, but not totally. So is that, I guess, is
Well,
that
no,
the logic?
the point of a blockchain is you get trust out of assuming everyone else doesn't trust anyone.
But that's the consensus side of it, right? So instead of the consensus side of it, let's look at, here, quarter. You know what quarter is? Actually, I had quarter in here, but I took it out. So the idea of quarter is that you encode an agreement into the hash of an agreement into a blockchain. Actually, another example is what BV Rio, which is a Brazilian materials producer, is doing with Ethereum, and they're storing hashes of agreements in a blockchain. And so because you have a version of events that is absolutely mathematically provable to have actually happened, that gives you something to work with. Whereas if you just have entries in a database, that doesn't carry the same weight.
Yep.
You know what I mean?
So when you have those hashes, why do you put them on the public
Well, in the case of BV Rio, they do use the public one. The problem, big problem is transparency, right? You don't want, like banks do not want to want their private. Yeah, that's a hash, right? But say you're actually exchanging account balances and stuff. You do not want.
You do that privately.
Yeah, you do that privately, and the way to do that is through a consortium or permissioned blockchain of some kind.
And then how do you get the security?
The security is just based. Then the security comes back to the provability of the chain of custody of those assets, right? Because well, you can prove it because you have a mathematically you have a clear chain of custody that goes. If it forks, that's when external judicial systems come into play.
That's what the public chain is for.
That's what the public chain is for, absolutely. But that's because we don't have the fallback of a judicial system in a public chain because we can't isolate a bad actor because they're pseudonymous, right?
No, even in a public chain, you still need to be able to fall back to something. And even in a private chain, you still need to fall back. If you fork in a private chain, what do you fall back to?
The auditors and then a legal and then a judicial system.
Then you just have a trust system.
You do, but I mean, because you've got a judicial system, you've got provability. You can prove you can prove a series of events.
But you don't need proof of work. You still get the distributed.
Absolutely, and you still have the global vision. You can see what's happening, and if two people disagree, if the thing forks, you can see, okay, so what actually happened? Did you actually send this money or didn't you? That's the beauty of it, and it brings it down to a single point, a single point where the fork occurs. That can be figured out by people in back rooms and courtrooms.
I was going to say as well, like the thing that I would say about this is that you're going to end up with substantial benefits in the form of like reducing counterparty risk and everything. So you'd end up in a situation where they'd say, well, look, there are substantial benefits, so that even if we have a hard fork and we've got a fallback of the judicial system, etc., you just say, net, it's a significant improvement on what we currently have.
Yeah.
Being able to
I think the point of the consensus is to, when you have a fork, tell you which one is the correct one.
Yeah, but that's why we have a legal system and auditors currently, right? That's the job that they do. So the idea is that this can keep us in sync until a point where we have a disagreement, and then we can fall back to our legacy way of doing
The whole
things.
system just grinds to a halt until the auditors figure out which one is the correct one.
Yeah, but it shouldn't fork. Like, when would it ever fork? When would a bank's records ever fork? Like, they never do. They're real tight.
Say one bank, like they have a malicious admin, right?
Okay, they have but that's easy.
Sells $1 billion worth of stuff.
But then they
And
can.
then the other banks are like, yeah, that was a good thing. And then they're like, wait, no, he shouldn't have done that.
But that comes down to like agency, right? So he had permission to do it. He did it. It's sold. That's the same as having a rogue trader, right? And there's no recourse there.
It's all trade-offs at the end of the day. It's classic computer engineering and what level of risk that you want your system to be able to tolerate and not tolerate, and what the consequences and impact are. So I think this is back to your point really, which is the modularization aspect.
Yeah,
People are cherry picking to engineer a blockchain solution that kind of meets their risk profile depending on whether they're out in the public, whether they're in the banking world, how closed the network is, how open it is, how trusted the parties are, etc.
Yeah.
The reason that it kind of works with Bitcoin is the financial reward for messing around with a little bit of the blockchain that you have control over, your single miner.
Yeah.
Is never going to outweigh the financial reward of just putting that mining power to actually mining. But if it was like a group of banks on 500 banks or something, it would only take a few of the banks to be able to conjure this weird reality, and then they could create this crazy reality, and then you're like, well, which of these two versions of reality is real? And you don't have the audit at that point because you just got one audit against another, and you don't know which is real.
But what you do have is a breakdown of global financial cohesion, because now those banks can't work together, And so there's a economic disincentive to ever fork the network. There's a massive incentive to always work together, because that increases their liquidity pool and gives them the ability that gives them access to one another's assets and the ability to collude over LIBOR rates and things like that. So if they, they shrink their. Yeah, well, that's probably the best description of a blockchain is an Excel spreadsheet, and then if you're going to look at a blockchain as an Excel spreadsheet, then your programmable blockchain is the spreadsheet with formulas and things like that.
Basically, in my opinion, if the banks are gonna run blockchains, you might as well, if you reduce it down to it, it's just the central bank decides how things run. So they might as well just run their own centralized cryptocurrency and kill all the banks.
Well, now this is what we come.
What's the point of the bank, the retail banks? Once you have an automated system where everyone can just integrate with it, right?
But then what we find is that you have a point where absolutely that's why not, right? Because they're the ultimate source of credit. Banks are really credit retailers, and they retail the credit that they get from the central bank. But why not commercial banks? Or what they borrow, right? Or what they loan, what they put onto their books. So, I mean, what do you do? It comes down to two competing models: commercial banking and central banking, and this is a disruptive technology, and it'll give whoever adopts it first an edge. How much of an edge? We don't know. Maybe enough of an edge to kind of beat the other. But I mean, central banking, they can print money.
Yeah, the other thing, and I think this is sort of the interesting part of the rise around the Bitcoin or the Bitcoin idea, was the idea of you can go post-state. So there is no central unit or there's no central kind of authority over a central over Bitcoin or really over Ethereum, and the ability to be able to kind of generate and then store value that sits outside of any other sort of entity. But then it's sort of what's the point of a bank? Well, it's there to store value, really, and it's there to store value and mean that in a trusted way. And so if all of a sudden I can come along and store my value somewhere else, ignoring volatility and Bitcoins and price relative to everything else, but it's that's actually you're providing the same kind of basic functionality in the protocol.
Yeah. So there you go. So what is the point? Sorry.
Talking about the banks, because I'm actually doing a project on regulation of cryptocurrencies, and the Reserve Bank is very interested, so is the BNA, and the Reserve Bank's got no interest in being a banker. It's looking after, it just wants the stability of the banking system. But one of the things, they released a bulletin on it a few months ago, and what they are worried about, the Reserve Bank, is that banks make profits, a lot of profits. But that actually evens out when there's peaks and troughs. And so if the money is taken out of the banking system, we don't use banks, so we just all use Bitcoin Ether and stuff, then that could actually upset everything. So,
I think the idea, though, is that we can build a system using essentially smart contracts, right? Once it becomes sufficiently mature and sufficiently reliable to replace the services that banks and central banks provide.
Yes, but the banks will fight against that.
Yeah.
If they write the law,
Yeah.
then they will keep with good stuff. What you've just been talking about, permission ledgers, they'll be using that gladly, but none of us will be able to use it.
They won't, well, they won't. I should probably just stop talking because I'm sure someone's got a strategy based entirely around this.
It could be closed down.
Absolutely, no, I fully, yeah.
Closed down, that system can't be closed down, but it's that companies, if they start dealing in Bitcoin, if they've taken Bitcoin, then they can't do their bank accounts will be closed down. So there are other ways of doing it.
Yeah, well, that's certainly happened.
But that's why it's called disruptive.
It is, I'm saying it's disruptive, but there's a tipping point now. So which way is it going to go?
It's going to go in favour of cryptocurrency.
I don't know, I just wanted to comment on that. I think banks are a little bit like energy companies, and energy companies don't want to get rid of all their oil assets right now because they just make crap loads of money out of it, but oil is, its future is going to be finite, and renewable energies, and I think blockchain is much like that to the banking system. It's coming, and the banks are thinking, well, we can make ourselves more efficient and make more cash, but they're not about to just basically press the button and basically just, oh, well, we'll make everything so simple now that all we're going to be is like a cryptocurrency wallet provider. You know, they're not about to just destroy their own business like that yet. So I think that's the tension we're going to see probably over 5, 10, 15, God knows how many years.
They want to remove the inefficiencies in their banking
Yeah.
system, right, by doing settlements of bank transfers and stuff as quickly as possible. Where they're going to use that to your advantage, right?
Yeah.
They're not going to unleash, they're just going to make it a free for all, right? They're only ever going to do what they've always done, which is to use it to their advantage.
But think of the advantage. Like it's easy because we're just talking about like systemic. Oh man, how good it'd be for just to be quick instead of waiting 3 days to get money, or a week if it's in the States. It's appalling how like slow their financial system is. They use checks in the States. But no, seriously, their entire banking system is built on checks. And it's just digital versions of it. It's like, you can't believe it. I mean, when you get paid in checks, it's almost horrifying having been in a civilized country. No, like they pile up and you've got like 6 weeks of checks and you're like, I've got to go to the bloody bank and like cash these, and you cash them, and then it's just like, yeah, I've got money. But it's, you know, you've got to do the actual trip, or you can send them in the mail.
3 days later.
Yeah, you do. And the thing is, if it's the wrong bank, you know, or if you're in another state, but think of all the time that capital is tied up for. And if you shorten those settlement times, you vastly increase the liquidity, not only the liquidity of the economy, but you know, the velocity of money and the amount of capital that is available. Because right now, think of all the money in the world that's tied up in bank transfers. That's globally significant. It's significant for the entire economy. And if we can free that up permanently, that's suddenly like there's just that much more money in the world.
I think that's the funny kind of thing. So like being Kiwis, we're used to FPOS and it just working and it being free and instant. And the rest of the world and the banks, they're looking at blockchains and thinking they're fast and you know, efficient. And they're the complete opposite of that. They're just like, they have this word to talk about where they can go, oh, we can like digital, we can automate our business by blockchain and fire everyone.
Yeah.
But really, like, all they need is a database where they like cross-check it, right? And then really the end, the decision makers are just, this is how much money you have, and we agree on that. But a blockchain is really like, the point of a blockchain is that like people are competing against each other. And if they're not competing against each other to ensure the security, I don't know why you would use that kind of architecture.
Okay, this is why, right? So with the reason we can use FPOS is there's only, how many banks do we have to worry about? Like, how many?
Well, less than 10.
Yeah, it is. You can count them on like less than this many fingers, right? Whereas in the States, you've got hundreds and hundreds. Hundreds, maybe 500 banks. Because you might have one brand, but the branches, the different area, the different state banks are owned by totally different companies. Same branding, right? It's like, why did that change? It's like Flybys, right? Or Loyalty NZ, they do everything. They literally do Flybys. The infrastructure that does Flybys does every single loyalty reward program in New Zealand, right? So in that sense, you've got this like, here we have this like consolidation. Over there, you've got, but Aussie Flybys, totally different company. Same brand, different company. And so for them, they've got just too much. They can't do it. But what they can do is they can say, okay, this is your node, this is your node, this is your node. Let's call them master nodes. And if one of those master nodes commits something fraudulent, then there's recourse to said master node.
Reversible transaction, reversible blockchain.
Well,
that's the new technology. Because banks reverse transactions all the way down the line. It's happened to many people here. They do a transaction and then a week or a month or a year later, the bank presses the button and it gets sucked back out of your account.
We can do that with Ethereum though.
Yeah, well...
yeah. Well, Tezos, I believe, is working on exactly that problem because reversibility is a feature. you know?
Isn't that not a feature? Isn't that a bug?
I mean, all features are bugs. It just depends on what side of the black line. Yeah.
I'd say because if someone sends you money and then it comes back out of your account, I mean that was one of the benefits of Bitcoin, was this unreversible transaction that you can trust that you've got the money, you can see the money, it's my money, I've got confirmations, nothing's going to happen to that money. If you suddenly change it to say, okay, well it's reversible now, that the value proposition pretty much goes up in smoke. You can say, oh, we can just make an Excel spreadsheet and just write some numbers on it, and then people can just share that.
But what you've done is you've just turned it into a binary, whereas actually there's lots of grey area in between. So what about, let's look at the conditions under which it becomes reversible, right? So say for one, a majority of the mining power, right? That is one condition under which a transaction can become reversible in say in Ethereum and in Bitcoin as well. Actually, is it in Bitcoin? You can censor them. Could you actually? You can fork, I guess. Yeah, you can fork with 51. Yeah, it has. So yeah, you can do that. But it's the idea is there's a.
You've got two separate systems then. It's like Ethereum. You still got the old system running.
Yeah.
And if you had a smart contract that was running on both systems, what system do you want to go with? I mean, legally, what system is actually the legal one?
Well, this is what's cool, right? Is because you fall back to social consensus. Because at the end of the day, the only thing that matters is social consensus. We are the only people who matter, right? The blockchain, who cares, right? If it is good, if that's the one you like, that's the one you like. If you don't like it, you don't like it. Don't use it. Don't agree with it. That's what consensus is all about. And we came to consensus in the in the case of Ethereum. I did. I sold my Ether Classic, right? Like real early. It's like too early, unfortunately, like way too early. But because it's an appendix, and
Ethereum hasn't finished. I mean, it's not provable yet. I mean, it hasn't proved itself as a reliable system. It's still proof of concept.
I agree. Yeah, it's the thing about it, right? Is it has to prove itself under bearing value, which is actually that's a totally different track to the idea of the ability to actually change transactions, right? Mutability, right? That's a feature just as immutability is a feature. It just depends on which one you want. And so just pick which one you want. If you want mutability, then there should be a solution. And I believe Tezos has it. I'm going to interview the Tezos people relatively soon to get the lowdown because it's easier than reading. But yeah. Yeah.
Build that into the contract, the reversibility, right? You can have a trustee or something.
Absolutely. Yeah.
So you don't need to have that as a feature of the blockchain if you.
But if you could build it into the actual core protocol, then you could avoid things where you fork and have, multiple tokens. But then if you could get rid of the tokens altogether, the base token, wouldn't that be great? If we didn't have to even have Ether or Bitcoin, if we could just have your issued currency on a secure database.
If things are reversible, though, they're infinitely reversible, and no one would ever spend anything.
Unless it's hard, unless you have to expend resources to reverse something, or
Well, yeah,
yeah, exactly. Well, actually, no.
It's only reversible to the extent that it's only irreversible to the extent that it's hard to reverse it.
This comes.
Something is
reversible
reversible
by consensus.
Yeah.
So whether it's private or public, it's always by consensus. It's immutable by consensus.
But how do you know what the consensus is going to be in the future? That's why you don't want things to be reversible, right? The reason why you want something to be immutable is you reverse something by transferring it back. Because then you have an audit trail that you sent it to someone and then you sent it back. You use whatever external mechanism you need to do to enforce the person to send the money back. That's how the regular system works.
Sure.
Again, it's a feature, right? Yeah. As well, it just depends on which side of the reverse payment you're on.
Yeah, so it depends how you do it, right? But when you publish a payment, it should be final. So if you have anything that you want not to be final, you don't publish it yet.
Yeah, but what if you made a mistake,
Where you just put checks and balances in before you finally.
yeah, but what I'm saying is, like, you know, mistakes happen. I mean, geez, I just think of how many.
You should be punished for making mistakes.
I've been punished, man. I've been punished. You know. Yeah, exactly. I mean, I can tell you, I have been. I've been hammered by like terrible errors in judgment with like sending Bitcoin and stuff. I remember waking up drunk one time after a big night out, and it was just like.
And you invested in the Dow?
Shit. yeah. Oh, geez. Totally, though, you know, totally. You make mistakes. People do make mistakes, and this has to be anything that interacts with humans has to be soft, because humans aren't like hard. They're not made of metal, right?
Yeah, I think a blockchain is supposed to be immutable, so you should take it upon yourself. If you want to have control, you have control, and then when you publish your signed transaction, you've given away that control.
It is. You're right. The point is, as well, is that when we interact directly with the blockchain, we're interacting with bare metal, and that's not for humans. It should be. There has to be some intermediary, and that's actually interestingly where UPort comes in, right? So the idea of like UPort is you have this like intermediary identity that can mediate you have an identity that then has a proxy contract, right? So the contract that you're actually interacting with, awesome design, by the way, this mechanism. If you lose your phone, right, you've lost that private key. But that proxy contract, what it can do is it can have a list of validators who can validate your a transfer of ownership to a new public key. And so you can say, get a new phone, new UPort ID, get your validators to scan it, and then reconnect with that proxy contract and re-adopt your old identity. And so systems like that, you need these intermediaries to protect us, basically, from, you know, idiocy, right? Yeah, idiocy and drunkenness, and because those are like that's what's sweet about life, right? Is, you know, the ability to make mistakes, and hopefully.
We've got time for one more question before we break up. Anybody else got any?
If I can ask a slightly more nuanced question, how do you, if you're sort of, you know, if you wanted to do it for more banking sort of things, then how do you do privacy? So I don't want other people to see what I spend on things.
Well, so this, actually really good question, and this is like fundamental, right? And that is that for banks, a public blockchain is not the solution, because a public blockchain is fully visible to all parties, all participants. So that is why you have a permissioned blockchain, where you might have the ability to access your account, but you don't have the ability to see, say, you know, you have this, again, you have the soft, you have something in an intermediary to prevent you from actually being able to see the blockchain, because that is the business of the bank, right? But you still need to be able to access the funds therein. So you have a card, and what that card does is every time you use it, it contacts the bank, and it connects to, and the bank uses that card to transfer the funds, but you never get to see what is actually going on the bank side, just as it is right now, you know, and that's why you can't have a public blockchain for a bank. That's why they need their secret permissioned environments.
So does that basically mean that you can't really do blockchain properly if you're doing banking?
You can't do consensus properly if you're doing banking, but what you can do is just have a blockchain and just keep it within your bank. It's your own private network. It's your own private walled garden. Think of intranets and internets, right? Intranets are closed off, and you know the internet is not closed off. And just like we saw with the internet, you know, it started out as these intranets, and then it opened up to be this global system. And with banks, what we're going to see, and what we're seeing right now, are these intranets, and then eventually the public ledger will presumably dominate, but those intranets still have value, and banks don't communicate with with internally through the internet. They have an intranet to transfer value internally over.
Intranet that sort of encompasses 20 banks, so that they've decided to share their intranet essentially, because they kind of trust each other, but they can't go public with the blockchain. So it's not true intranet, just the companies. It's interbank.
There is the internal, and it's quite funny, but it's more common in America where there's been mergers and acquisitions. So even within a bank that does employ thousands of people, they've got different systems of record depending on who you initially opened your account with, and they've got parallel systems that have different account balances and are all trying to reconcile internally. So even in that space, there's a value of a blockchain to be a new system of record and have all the other systems actually read from that and kind of trust that within a bank.
That's actually well put as well. It's a new system of record, and it's one that we desperately need because it's not the 80s anymore.
Or the 20s, for that matter.
Yeah, right, totally. Good stuff. Thanks, guys. Hey, good question. Thanks, man. Awesome. Arthur, by the way.
Chris.
Yeah, Chris. No, you know my name. But, you know.